Welcome to the DIY Honda Garage channel. The DTC P2128 indicates an issue with the APP sensor B, specifically related to the throttle position sensor E circuit registering a high voltage. The APP sensor, or accelerator pedal position sensor, is crucial in regulating the throttle opening based on the driver's input, connecting directly to both the throttle body and the engine control module, ECM, or powertrain control module, PCM. Located in the footwell area of the vehicle, it allows for precise control of the engine's power output. A fault in this sensor can lead to poor acceleration or even stalling. Understanding this fault is essential for diagnosing and repairing the vehicle to restore proper functionality and ensure safe operation. The APP sensor B is integral to the vehicle's throttle control mechanism, translating the position of the accelerator pedal into an electrical signal that the ECM interprets to manage engine performance. Specifically, this sensor provides feedback on how much the accelerator pedal is pressed, enabling the throttle body to adjust accordingly and maintain the optimal air-fuel mixture for combustion. With its location in the footwell area, the APP sensor is frequently exposed to physical wear, potential moisture, and electrical interference, making it vulnerable to faults. A failure in the circuit often triggers DTC P2128, indicating high voltage conditions that can compromise engine response and efficiency. Therefore, accurate diagnostics and repairs targeting the APP sensor and related components are essential for restoring optimal vehicle performance. In diagnosing DTC P2128, several potential causes must be considered. Firstly, a faulty APP sensor B could lead to inaccurate feedback being sent to the ECM, resulting in the high voltage error. Additionally, poor connections such as corrosion or loose terminals at the APP sensor or the ECM PCM may disrupt signal integrity. These connectivity issues are critical as they can intermittently cause high voltage conditions while appearing fine under normal operation. Furthermore, a malfunctioning ECM or PCM can incorrectly interpret signals, leading to erroneous operation of multiple engine management systems, including throttle control. Each of these causes warrants thorough examination and testing to ensure a comprehensive understanding of the root issue behind the fault code. The symptoms associated with DTC P2128 can significantly impact the driving experience. One of the immediate indicators is the illumination of the check engine light on the dashboard, alerting the driver to an underlying issue within the engine management system. Poor acceleration is another common symptom, as the vehicle may struggle to respond to throttle input, leading to frustrating driving conditions. Furthermore, in severe cases, the engine may stall, particularly during low-speed maneuvers or when stopping in traffic, posing significant safety concerns. These symptoms not only indicate a problem in the APP sensor circuit, but also highlight the necessity for prompt troubleshooting and resolution to maintain both performance and safety. To initiate the troubleshooting process for DTC P2128, begin by turning the ignition switch to the on position without starting the engine. Next, utilize the Honda Diagnostic System HDS to check the data list for APP sensor B. This will allow for a detailed voltage reading from the sensor. Ideally, you should see a voltage reading of about 4.0 volts or greater. If this reading is confirmed, it indicates that the sensor is receiving adequate power and is functioning in that regard. Conversely, if the voltage is under 4.0 volts, it suggests a potential intermittent issue, leading to further investigation, including checks for loose connections or terminal issues at both the APP sensor and the ECM PCM. Following the initial checks, turn the ignition switch to the lock 0 position to safely access the components. Disconnect the APP sensor 6P connector, a crucial step in further diagnostics, as it eliminates any interference from the sensor itself. Next, turn the ignition switch back to the on-to position. With the APP sensor disconnected, measure the voltage between terminal number 5 and terminal number 6 on the APP sensor 6P connector. This measurement is essential for determining the functionality of the signal being sent from the ECM. If the voltage reading is around 5 volts, this indicates that the power supply is intact, guiding to step 12 for further checks. If not, the subsequent steps will lead to an analysis of other underlying electrical issues. After measuring the voltage in the previous step, turn the ignition switch to the lock 0 position for safety. Then, you will need to utilize the HDS to jump the SCS, Service Check Signal line, which prepares the system for diagnostic checks related to the ECM PCM. Following this, it is critical to disconnect the ECM PCM connector A, consisting of 49 pins, to isolate the signal from the processor. This step is imperative as it ensures that you are directly evaluating the interaction between the APP sensor and the engine control unit without interference from other signals within the system. These procedures are geared toward narrowing down the root cause of the high voltage issue logged by the DTC. In this step, the ignition switch remains in the lock 0 position, while you will connect the APP sensor 6P connector terminal number 5 to body ground using a jumper wire. This setup allows you to test the system's grounding, which plays a vital role in ensuring that electrical signals return correctly to the ECM/PCM. Next, check for continuity between the A27 terminal at the ECM/PCM connector and body ground. This is an essential test to assess whether there is a direct electrical path for the signal from the APP sensor. A successful continuity test will suggest all grounding systems are intact, while failure might indicate issues in wiring or connector integrity that could contribute to the high voltage condition triggering DTC P2128. After completing the troubleshooting and necessary repairs for DTC P2128, it's critical to confirm the repair effectiveness. This can be achieved by running the vehicle to observe real driving conditions, which can help in monitoring engine performance under various loads and speeds. Pay close attention to the throttle response to ensure it operates smoothly and without delays, indicating that the APP sensor is functioning correctly. After successfully running the vehicle, recheck the DTC status using the HDS to verify that the error code does not reappear, confirming that the issue has been resolved. This verification step is integral to establishing trust in the resolution made during repair, ensuring that the vehicle is safe and dependable for ongoing use. To prevent issues such as those leading to DTC P2128 in the future, implementing regular preventive maintenance is essential. Begin by routinely inspecting the APP sensor B, ensuring that its connections remain secure and free from wear or corrosion over time. Regular checks help to preemptively identify potential issues before they result in failure. Additionally, checking electrical connections, including those at the ECM/PCM, can prevent voltage irregularities caused by loose or corroded terminals. Maintaining overall vehicle cleanliness, especially concerning the footwell area where moisture and dirt can accumulate, will help protect sensitive components like the APP sensor from unwanted interference. Effective preventive measures not only enhance vehicle reliability, but also extend the life of critical engine management components. In conclusion, DTC P2128 signifies a circuit high voltage problem prevalent in the APP sensor B, essential for throttle control in the Honda Accord from 2008 to 2012. Understanding the diagnostic routines and thoroughly exploring each potential cause is key to effectively resolving this issue. The troubleshooting steps outlined provide a systematic approach for accurate diagnosis, ensuring that technicians can pinpoint and resolve problems related to voltage irregularities in the APP sensor circuit. Preventive maintenance is equally important to help avoid recurrence of such DTCs and maintain optimal vehicle performance. Through careful monitoring and timely intervention, owners can enjoy a well-functioning vehicle that responds effectively to driver inputs, allowing for a safer driving experience. Please like and subscribe to the channel. See you next time.